For number 26, we're told that we have a savings account of $3,000, so that would be the P, with an interest rate of 6.8%. So 6.8% as a decimal would be 0.068, that would be R. And then part A wants to know how much interest would be earned in 2 years if the interest is compounded annually. So 2 years tells us that T is 2, and compounded annually, that would just be once a year, so N would equal 1. So plugging that into our compound interest formula would look like 3,000 times 1 plus 0.068 over 1 raised to the 1 times 2. So what that would look like to get it in our calculator, we'd have 3,000 parentheses 1 plus 0.068 divided by 1, close parentheses, exponent button, new parentheses, 1 times 2. And to the nearest cent, we get approximately $3,421.87. And then part B wants to know how much interest will be earned in 2 years if the interest is compounded semi-annually. So P is still the same, R is still the same, T is still 2. The only difference is now, since it's compounded semi-annually, that would be twice a year. So N would equal 2. But we're still using the same formula, same compound interest formula. The only thing that's going to change is we're going to have a 2 in place of the N instead of a 1. So to plug that into our calculator, we'll have 3,000 parentheses 1 plus 0.068 divided by 2, close parentheses, exponent button, parentheses, 2 times 2. And again, rounding to the nearest cent, we get approximately $3,429.28. So part C, in which case do you make more money on interest, and why is this so? So you can see that we made a little bit more than $7 more in interest in the compounded semi-annually situation versus the compounded annually situation. And that's just because that in this case, you're getting that interest added to your account after 6 months. So then the next 6-month period, you're earning interest not only on your original $3,000, but the interest that was deposited after the first 6 months. And in this case, you're waiting until the end of the year to receive all of your interest. So that's why it's going to be a little bit less in this situation. Number 32, we're told that the interest on our credit card is compounded continuously. So just seeing that key word there tells us that we're going to use the A equals P times E to the RT formula as opposed to the other compound interest formula. And we're told that we have an APR of 19.8%. So that means R is going to be 0.198, converting that 19.8 to a decimal. And if you put your first term bill of $39.84 on your credit card, so that's going to be the P, $39.84. But do not have to make payments until you graduate, which is 4 years later. So that's going to be the T. How much will you owe when you start making payments? So we're going to take this formula and plug in this information. So we'll have A equals P is the $39.84 times E to the R is 0.198 times T is 4. Now what that would look like to get it in our calculator is we'd have 3984 second ln to get the e and the exponent, and then 0.198 times 4, and to the nearest cent we're looking at $8,795.91 is what that 3984 would grow to after 4 years.